Alrighty. Finding 3-digit even numbers. Easy. You are given an integer array of digits, where each element is a digit. Okay. The array may contain duplicates. You need to find all the unique integers that follow the given requirements. The integer consists of the concatenation of the integer. You find all unique integers where the integer is concatenation of 3 elements in any order. The integer does not have any leading zeros. The integer is even. So find all unique integers, return a sorted array of those unique integers. Okay, so 2130, so it has to end with the 2 or the 0. And then it needs to be 3 digits, so it could be, well, it could be any of these, okay. It needs to be sorted. Alright. Interesting. So, okay, so the answer is going to be an array of values. And maybe I can have an evens array that just looks at the possibilities. Evens array that looks at all the possibilities. All the possible even endings. So for every d in digits, if that number is even, which is the remainder is 0, remainder by 2 is 0, evens.append that number. So then these are the numbers that you can have as the last digit. And you don't want duplicates, right? No, the array may contain duplicates. So for instance, you could have multiple 2. What does it mean? Oh, the initial array may contain duplicates, but this is the unique integers. Okay. The initial array may contain duplicates. Huh. Well, I guess I can say here, if the number of evens is 0, then you can just return nothing. So that'll solve case 3 of all odds. So what is the deal here? Let's say I have this. What is the idea? So they're all evens. So my evens array would just be the same as the digits array at that point. So what would you do? So for every non-zero starting digit, and then every secondary digit, you pair it with one of the evens digit, assuming that there was enough, assuming you hadn't used all your values. So there's 3 2's, so you can do 3 2's. So it's 100 in length, so it could be pretty long. It can be pretty long. Really, if there's only, like, you can only have at most 30, right? 10 for the first digit, 10 for the second digit, 10 for the third digit. So Some of these are just going to be irrelevant. So all you really care about is the first three of any digits. Because like if you get a 4-2 or 5-2 or 6-2, it doesn't really affect the possibilities. You only have a 3-digit number. So I guess for each number you can determine if it has 0, 1, 2, or 3 or more of that number, of that digit. And then what? Then you run through the possibilities. Huh. I feel like there should be, probably do some sort of, the issue is the fact that when you use them up, it goes away for later possibilities. And there should be a quick way of doing that. Maybe backtracking. So, and then you use a evens digit as your ending digit. You can't use it as one of your starting digits, maybe. So, have some number of starting digits. So for each starting digit, going from the lowest to highest, each starting digit going from the lowest to highest, well, the starting digit isn't 0, it's going to be your hundreds digit. And then for each tens digit going from lowest to highest, not including a count of digits that you use for your starting digit. Interesting. So here, starting from 1, then, so you have 1, so what if you have your hundreds, tens, and ones place? So it's like 1, 2, 3 as your possible hundreds. So this is for digits is 2, 1, 3, 0. And then when you do your hundreds, you say your tens is either 2 or 3. And then when you do your ones, it's, no, the tens is 0, 2, or 3. And then you do your ones, and it's either 2 or 0, 0, 2. There's a lot of if statements that seem to be popping up in my head in terms of checking for counts and seeing if the digit, if the thing is not too many in terms of the digits used. All possible. Notice there are no odd integers or integers with Leetcode symbols. So you start with a 1, take all your digits, you remove 0, sort them. Start with a 1. I wonder. Pretty high acceptance rate. I wonder if this is, I'm just overthinking it. What if you just sorted your array where you put your zeros at the end and sorted your array, put the 0 at the end. What if you tried all possible combinations and just did a check to see if it's possible at the end? Is that slow? That seems pretty darn slow. What if you did a reverse? What if you start with your even numbers, then you have to sort at the end. I guess sorting is probably not that long compared to what else you're doing here. So what if you started with your even number? If you start with the even number, it's going to be... How would you handle 0 in that case? So you start with by making your ending. So it's either going to be 0, 2. And then you have your 10s. And then you have your 1s. And then you just reverse the thing. Then you just reverse the thing. Two, 0, 1, 0, 2, 1, 2, 0. Start with an even number. Make that your hundreds. Have some method to reverse. Start with even numbers. So hundreds is like 0, 2. And then if it's 0, then it's like 1, 2, 3. And then it's whatever's remaining. 2 or 3. Maybe make a set out of this. All unique consists of 3 elements in any order. Integers does not have leading 0. Integer is even. I guess. So you have a starting value, and then you have some values after that that depends on the starting value. And then you have some values after that that depends on that. Could handle duplicates separately. Could handle duplicates separately. Because your duplicates could be there's only so many duplicates that you could have. Like in terms of triplicates, there's 3 2s, 3 4s, 3 6, 3 8s. And in terms of numbers that have the same value either be 2 odds within your evens as you're starting, or 2 evens with any of your 2 evens plus an odd. No. 2 odds and any even, or any non-zero plus an ending 2 evens. Oh, I guess it could be 2 evens and any other even. Oh, jeez. Why is this so hard? So I can go over the uniques, the duplicates, and the triplicates. Let's say I have a frequency, which is digits, the counter of the digits. So that gives me for every digit the number times that occurs. Let's say I have my uniques, which is the set of frequencies. Let me go and print that out to make sure I think it is what I think it is. Yeah, okay, so 0, 1, 2, 3, 8, 2, 3, 5, 7. And then say I have my doubles, and that's it for every val in frequencies. If the frequency of that value is greater than 2, greater than or equal to 2. And doubles that append that value at the frequency of that value is greater than 3, then triples. And I guess if the value is odd, or sure, I'll go evens and odds as well. And odds, doubles, triples, they're all empty sets. empty arrays. Okay, if the value is even, evens dot append the value, else print the doubles, triples, evens, odds. Okay, so there's nothing that's double, nothing that's triple. Evens are 2, 0, the odds are 1, 3. Not sorted. Okay, so here there are doubles, 2 and 8s are has at least 2. Triples, there's 2. 2 and 8 evens. There's no odds. Okay. Let's see. If I were to do all the possibilities, so for every unique combination, so I could go through and do unique combinations. So I could do it in reverse order, starting with an even, removing it from my uniques. Okay, so something like for every even in my evens, if the even is 0, just continue. Okay, I'm gonna have num. That's initially 0. And I'm going to do num plus equals this even. So this is going to be like my ones digit. Well, this is my ones digit then. No, this is, what am I thinking of? Yeah, this is my ones digit. I guess my ones digit could be 0. What am I doing? Every even, it evens. The number starts with that even. And then it's going to progress to my tens. The tens, I need to remove it from my set of uniques. Uniques dot remove this even number. And then for every 10 value, for every t in uniques, so of my remaining values, any of them could be my tens digit. So num plus equals 10 times t. And then I need to remove this from my uniques again. Then that's going to change uniques. So maybe I need to duplicate. Duplicate the set. Tens is equal to the set of uniques. And then tens remove this even. Then for every t in tens, and then every t in tens, and then for every h in, actually, maybe I shouldn't just remove it, maybe I should just, for every even number, and then for every other t in uniques, if t not equal to the even number, then the number plus equals 10 times t. And then if the t is equal to even number, then continue actually. Just skip this one. And then for every h in uniques, if h is 0, if it's not the same thing as my tens or my even, so h not equal to my even, okay. This is poorly, for every ones digit, where the number is now equal to ones digit, and then for every tens digit, where the tens digit is not the same thing as the ones digit. If the tens digit is equal to the ones digit, then skip it. Okay. If the hundreds digit is equal to 0, or if the hundreds digit is equal to the tens digit, the hundreds digit equals the ones digit, skip, I guess. And then otherwise I do the number itself is 100 times the hundreds digit, tens times, or 10 times the tens digit plus the ones digit, and then the answer appends this number. So this should be working for all unique values. Okay, that should be working for all the unique values. And now for every val in the triples, if that value is not 0, if that value is an even, and that value not equal to 0, the answer.append 100 times that value plus 10 times the value, 100, 111 times that value, so like 222, 444, 66, 38. And for every value in doubles, for every value in my doubles, So if the value is odd, actually let's do the odd one first. Value is odd, then it must start. It can't be the ending two values. And I compare it with any evens. So for every even in my evens, answer.append 110 times the value. So that's like 330, no, 100, 110 and something, 330 and something, 550 and something, plus the even. And that's the only way that you can get two numbers where there's odds, two odds. Else, if it's two numbers, if it's two evens, then it can pair, then that can do anything besides 0 in my uniques as my leading number for every uns in unique. If Huns is 0, continue. Or if Huns not equal to 0. And then answer.append. That's not quite right. Like the unique could have something that's like a double. It could have something that's like a double. Oh, I think maybe if the hundreds is if it's not the same thing as my value. If and Huns not equal to value, then because it'd be covered as a triple in that case. Then you can start with it. So it'd be answer.append 100 times 100 plus 11 times the value as their ending, like double zeros, double twos, double fours. Alternatively, it could be the two doubles that are even is the first numbers, and then it can be any other number at the ending. So if the hundreds, so the double value is so if it's 0, if this, okay, let's say this is the other value that's not the double value. So if the other value is 0, well, let's say if the Huns equal this value, then just continue. So here we're dealing with two things that are not the same. And if it's not the same, if it's 0, oh sorry, this is other. If other is 0, then this only works as the non-hundreds version, so it's like two doubles in the 0. Well, it's going to be just that 220, 440. Else, if it's not 0, then it can be used as, so we're dealing with evens, right? So the value is even. So if it's even, then you can do anything as the hundreds. Append this other value as the hundreds plus 11 times this double's value as the last. or this doubles value as the last plus no. This thing, this double value as the last only if the other value is even. So if the other value is 0, then just do this. Otherwise, do this, and if the other value is even, then append this as the last digit. Okay. And then answer.sort. Alright, this was really other values even. Shucks. So it's missing 228. So it should be this thing. If the values, if my double value is even, which we're talking about here, 2. So 2 and 8s are my double values. So if my double values is even, for every even, actually I think this is opposite. It should be every, if value is odd, then it matches with any even. Yeah, I think I did that just opposite what I was thinking about. Uniques. Okay. So if my doubles value is odd, I compare it with any evenness ending. If my double value is even, like 2 or 8, then for every other uniques, where the other doesn't equal value. Oh, the double could be oh, shucks. Actually, I was thinking that it should be 2A8. I think 2A8 should have been covered. I was thinking the doubles is the same spot, or adjacent spots. The other value doesn't match. If the other value is 0, that doesn't really matter here. The other value is 0. Then it has to be 0 is the ending, or 0 is the tens digit. Okay. Else, if the other value is something besides that, and we're dealing with an even double, other value times 100 plus 11 times the value. I thought that would give me 288. No. The value itself is 8, the other value is 2. answer. The value. Oh, yeah, I do have 288. I just don't have the 282. Okay, yeah. It's misreading. What's the error here? Answer append. So this is where the even value is the first and last, first and second. No, this even value is this. Last two. So the other value could be the tens digit, and the value itself could be the ones and the hundreds digit. Okay. So here, it should have. Oh, what is going on here? Could be double zero. Man, I have a feeling that all these if statements, I could have just maybe had a sanity check at the end. That's fine. Okay, so if the double its value is 0, then what am I doing here? So it falls into this if statement. So the double values is 0. Can't actually. Every other uniques. Okay, if the value is equal to 0, then for every other in uniques, if other is not 0, man, I'm tempted to do a set that just has uniques minus 0 to get around some of this mess. Other. Can I do that? Uniques not including 0? Yeah, whatever. Other value is not equal to 0, then answer.append 100 times this other value plus, well, 100 times this other value, and then continue. And then here is when the value itself is not 0. Okay. Okay. Well, I mean, that was this horrible logic. I think maybe, I know that there has to be a better way, but it's fast. I wonder if any other way was as equally fast. Guess there were definitely some slow solutions out there. Is there something called permutations? Yeah, okay. I mean, for every ijk where they're not the same. Oh wow. This is literally going through all possible things. Guess they do have a set here. Yeah, so now this is going through all possibilities, and then they add it to a set, so the set removes the duplicates, and then sort it. Yeah, I mean, that would probably be the more general way of doing it. Here, and that's certainly something that probably flashed through my mind. It's faster to have this logic, even if it looks really bad, because it doesn't have duplicates. It's literally, because it's only 3 digits, it's finite enough that you can kind of hard code the logic. If this was like, if I had to deal with something where I'm dealing with 10 digits, this logic is just not going to be possible, or wouldn't be efficiently. It'd be faster still, but I wouldn't be able to branch out every single possibility. Okay, so I guess here the summary is this is a very inelegant solution. Elegant, kind of hard coding, hard coded, hard code, hard logicked solution whereby all possible kind of configuration of 3-digit even numbers are tried. So, like 3 unique digits ending with an even digit. 3 same digits, where it has to be a non-zero even number, and one or two same digits and one other digit, and that obviously has a lot of possibility. And that's this last thing here. Like, I just thought of those two digits either being evens, in which case, or odds, in which case they have to be the first 2 numbers of 3 digits, or if they're even, then they're first the first 2 if it's not 0, or if it's 0 then it's not if it's 0 then some other number has to be the hundredth number. Yeah, some other number has to be the hundredth number. If it's not 0, then if it's not 0, that's duplicated, that's an even number, then it has to be paired with some other number for for all the cases, pretty much. Like, this is some other number needs to be used as what is this doing? So if it's even number and the other number is 0, yeah, so if even number is some other number 0, it has to be like 220 or 440 or 2202 or 404. And if the other number is not, or if the other number is any other number besides 0, then it could either be the starting number or the 10th digit paired with this even number, or the last digit if it's even. Well, anyways, it's pretty convoluted. Time complexity, this is going to be O of, what is the time complexity of this? What is it doing here? It's almost, because you have a set amount. Yes, the question is like how many digits you're dealing with. If you had like n digits, then this kind of scales with that. And it scales with the number of size of your, so it's at least O of D, the number of digits that you have in your, like this is 10 digits, right? And O of S, where D is the digit set, which is to say total number of digits. Like this is your base system, base number base system, and S is the size of the numbers, how many digits are concatenated. It's at least that much. It might be some factorial or some polynomial of that amount. This is just a weird time complexity, I think. This is not usual. Space complexity, this is still O of, you don't really use any extra space here besides the set, so it's O of D. O of D for the unique sets. Unique doubles and triple sets that I'm tracking. Although if the size of the numbers increases, so like you have more than 2 or 3, then more sets are needed. No, this solution does not scale. Not a general solution for any size of integers, particularly logic will be much more complicated with increasing number of digits, increasing size of number.